Okay, so 802.1q sounds complicated, but I'm going to show you guys everything about 802 and trunking today, and it's going to make your life much easier to understand. I got here another packet tracer activity, and today we're going to talk about why do you need trunking protocols. So today here we got this packet tracer. This is packet tracer number 06. And we have a topology here. We have 3 PCs and 2 switches. From the previous videos, I showed you guys how to configure a VLAN, how to assign PC 1, 2, or 3 to a specific VLAN. I got this packet tracer from Jeremy's IT lab, and the link is going to be down in the description below. So just go ahead and download. Try to practice and configure it yourself before we get into the video, before you watch the video. So here we got PC1 connected to switch 1, and PC2 switch 1 as well, and PC3 switch 2. These switches are different from the other ones because these ones are layer 3 capable. The layer 3 switches, they're able to function at a layer 3 of the OSI model. The other types of switches, like in the last video, they were layer 2 switch only. This ones are layer 3 because they can route IP packets other than just MAC addresses. And because of that, we have the 802.1q protocol, and I'll show you guys why. So first of all, ping between the PCs to test connectivity. Let's go PC1. I want to ping PC3. PC3 has an IP address of 10.0.0.3. Okay, that works, which is expected. Now PC2, I'm gonna ping PC3 as well. Go ahead, ping 10.0.0.3 from PC2. It does work same way. Now PC3, ping PC2 from PC. Okay, command prompt from PC3. I'm gonna ping PC2 10.0.0.2. Okay, so there's connectivity both ways. And the second part of this assignment is to assign PC2 and PC3 to VLAN 2. We're gonna go on our switch 1. We're gonna enter privilege exec mode, and then I'll just move my mic to the side real quick, and then you're gonna type in config T or configure terminal to go into global config mode. Now what you want to do, you're gonna want to look at the switch port that PC2 is connected to. So in this case, it's F03. Let's go ahead. Let me just close this out. Let's go ahead and enter the interface of port F03. Interface F03. Now we're gonna issue the command switch port mode access, because I'm doing access because all we need to do on the switch is to declare or to state that the port that the PC2 is using is a switch port, because the switch needs to know whether it's a trunk or it's an access port, because it's an end device, it's a computer accessing the switch. The same way over here on the other side, on PC3, on switch 2, I'm going to go into the CLI and enter privilege exec conf t. I'm going to enter into F02's interface, because that's where PC3 is connected to. Switch port mode access. Again, we're stating that that port is an access port for the end device that's connected to it. PC3, PC1, the same thing. Okay, so we're gonna go to the CLI again. So previously we configured port F03, but just make sure you exit. You're gonna type in exit to exit that interface, because now we're gonna go into the next interface, which is interface F02. And for that same interface, we're gonna go and do switch port mode access. And I mistyped something here. We'll do it again. There we go. So these computers are properly configured. We now need to assign PC2 and PC3 to VLAN 2. So switch. I'm gonna go ahead and exit. And if you want to create a VLAN, you just basically state that you need the VLAN 2. You're gonna write VLAN 2 right there, and it created automatically the VLAN for you. And for that VLAN, notice that we are inside the VLAN right here. So if you want to configure further the VLAN, you can. What you can do now is exit. You're going to go into interface F03, because we're going to configure PC2. We entered and switch port access VLAN 2. So now we assign PC2 to VLAN 2. We're going to do the same thing on the other side over here with switch 2 for PC3. I'm going to exit. Or I guess in this case I didn't have to. So switch port access VLAN 2. Before I press enter, notice that I didn't create a VLAN 2 on switch 2, but that's perfectly okay, because the switch is going to handle that for us. Once I press enter, okay, so I mistyped this. Well, first you got to go into the interface. Okay, now you can do switch port access VLAN 2. So there we have it. Access VLAN does not exist, creating VLAN 2. So I created VLAN 2 and assigned PC3 to VLAN 2 for us. Okay, so that part, we're good. Now create a trunk between S1 and S2. So here's what I want to explain to you guys. Why do you need a trunk? Because let's just forget about the second switch for now. Let's just think about this segment over here. If we only had one switch and the device is connected to that one switch, that's one LAN. You know, the switch will automatically know which PC, which device is connected to its port. So we don't need to, we don't need to tell anything else to the switch to do, because it knows which computer it's assigned to each VLAN. But now if you want traffic to go from this LAN to another switch, then you need some sort of communication, because the other switch that's going to receive the message or the frame or the connection is not going to know to which VLAN on the other side it has to go to. So the computer engineers, they thought of a clever way to do this, which is the 802.1q encapsulation. So this encapsulation, 802 is a IEEE standard. It's an industry standard, and they make these technologies, they develop these technologies in such a way that can handle all the connection between network devices. The way they do this, on an Ethernet frame, you encapsulate, you add another information for when the traffic travels from one segment to another, it knows which, it tells the next device that's going to receive it, it tells it that that segment, that information, that piece of that frame has to go to VLAN 1 or VLAN 2 or VLAN 3, whichever it is. So it continues traffic, it knows what to do with that traffic. And that's why you need a trunk port as well, because it treats traffic in a different way. So F1 is going to be my trunk port port because it's connected to another device right there. And so if you go to the CLI, let's just go ahead and exit this. It's still on global config mode, but I'm gonna go ahead and go into F01. And in F01, we're gonna do the same thing as we would for an access port. We're gonna do a switch port mode trunk. This is how you would normally configure a switch. However, you're gonna see that that's not gonna really work because we're working with a layer 3 switch. If it was a layer 2, the algorithm, the system inside the switch would just handle that automatically, because I'm talking about encapsulation. So look, it says right here, an interface whose trunk encapsulation is auto cannot be configured to trunk mode. And that's exactly what we need to do. We need to specify the type of encapsulation we need for this trunk link to work. There's only main two encapsulation mode. The most famous and industry standard is the 802.1q. There's a funny story on the name of this encapsulation, this protocol, this standard. I think 802 is August. It's because it's 802 August 2nd. That's when they invented the technology. I'm not sure. You can look it up, but it's very interesting. So there's 802.1q and the ISL, which is a Cisco proprietary. In this case, we're going to use the 802.1q. We are in the interface already, so okay, so switch port trunk encapsulation.1q. We just told the switch to use the encapsulation.1q, and once you do that, now you can go ahead and set the port to be a trunk port. So switch port mode trunk. There we go. If you get these message right here, the syslogs, you can see that modifications were made to the interface, and you see fast 0 Ethernet 01 change state to up. That's a good sign. Now we're gonna do the same thing to the other side. So yes, so just try to remember that encapsulation, it's just a way of, like, let's say if you in the mail you have like a letter to send. Obviously you're gonna see that the letter needs to go somewhere in the world, and so different post offices needs to follow instructions to know where it's coming from and where it's gonna go. So sometimes you have additional information to help guide whoever is receiving the information to make sure it goes to where it has to go, more specific. Same way over here, we in the Ethernet frame, we just adding another parameter so when it travels to the other side of the segment, the other device will receive the information and be like, hey, okay, that's this is VLAN 2 that is gonna go to. So do the same thing over here on the other side. I'm gonna exit over here. So interface F01, switch port, trunk, and cap. If you type in cap, if you don't want to write the whole word, you can just press tab. It will just autocomplete for you. Encapsulation dot 1q. Okay, there you have it. Then switch port trunk mode trunk. There you go. So now that we finished configuring what we got to configure, we have to test connectivity. And if you want to test connectivity, always ping from one side to another. So now ping between the two PCs. Remember, in the beginning of the video, the pings were going through both ways, both directions, right? From PC1 to PC3, from PC3 to PC1 or 2, vice versa. So now what it should do, what we expect it to do, is for PC1, because PC1 is not assigned to any VLAN, we expect PC1 to be in native VLAN. As you know, in Cisco, they say if you don't configure It's, you know, it comes already pre-configured for you for VLAN, for native VLAN 1. It's there's a few configurations for security on the switch that you have to make for the VLAN 1, which I'm going to talk in the next video, maybe, I don't know, in another video in the future. But basically now PC1 cannot communicate with PC3, and PC1 cannot communicate with PC2 either, because they're both different VLANs. So PC2 has to be able to communicate to PC3. Okay, we made our trunk connection. PC2 are in this. PC2 is in the same VLAN as PC3. So let's go to PC1. I'm gonna go to command prompt. I'm gonna type in ping, and ping. What's PC? I'm gonna ping PC2. PC2 IP address is 10.0.0.2. Okay, pinging PC10 10.0.0.2. As you can see, if the first request timeout, if it does expire, if it doesn't go through, it's still okay. But if the second one gives you that message, request timed out, that means the connection did not form. So pings, ICM pings cannot traverse that segment right there. You see, even though they're in the same switch, they're separated by VLANs. So what happened right now was expected, so it's a good sign. So now PC2 has to be able to communicate with PC3. I'm gonna go ahead and type in ping 10.0.0.3. As you can see, the reply and the 4 pings, the 4 packets that were sent, which are 4, were received, and so therefore there's a connection there. You can see all the timestamps and time to live. This packet tracer is basically very simple, but the most important thing that you need to know for the CCNA test is that, you know, the trunk and why you need trunk. Just always make sure you do trunking from both sides. If the switch is a layer 3 switch, just know that you're gonna have to do the encapsulation. And on the CCNA, most times when I took my CCNA, I got my certification right there. You do have the labs where you need to configure the layer 3, and you need to specify the encapsulation. I remember exactly in my labs because I had to do the same thing. So encapsulation.1q, and by the way, it's using the same link. You know, it's amazing how this technology works, because it's only one link that's being used, and yet you have all this technology to kind of like encapsulate information, decapsulate on the other side, and tells all the instructions to do with that package. So it's pretty cool. Okay, so that was it for today's video, and I hope you liked it. Just make sure you leave a like and subscribe to my channel. This is my second official video of the channel. I want to make more videos for you guys, and the quality of the video in itself, it's gonna be even much better as I go. So everything is just practicing and, you know, doing them a lot of times. Similar to the packet tracer, the more you practice, the better you get, the faster. And so thank you for watching, and I'll see you in the next video. Thank you.